There is a rusted wrench sitting in a garage somewhere right now. Maybe it belonged to a grandfather. Maybe it came from an estate sale for $2. It is covered in a thick, scaly crust of rust so bad you can barely read the brand stamped into the steel. And here is the trick. You can drop that wrench into a bucket of water tonight. Walk away, go to sleep, and wake up to find it looking like it just rolled off a factory floor. No scrubbing, no sanding, no grinding, no harsh chemicals that eat through your skin. Just a bucket, some water, a couple of dollars in supplies, and a low-level electric current doing the work while you rest. That is not a sales pitch. That is the power of electrochemistry. And once you understand how it works, you will never look at a rusted tool the same way again. If you are new here, please hit subscribe. Let us start with the problem, because if you have ever tried to fight rust the conventional way, you already know the frustration. You go to the hardware store. You pick up a wire wheel attachment for your angle grinder. You strap on your safety glasses, fire up the machine, and press it against the rust. The noise is deafening. The sparks fly everywhere. Orange dust fills the air. Your arm aches after 10 minutes. And when you finally stop and look at what you have got, the rust is mostly gone. But so is a layer of the actual metal underneath. The edges that used to be crisp and sharp are now rounded and soft. The threads on the bolt you were trying to save? Gone. The fine stamping on the tool head? Blurred beyond recognition. You have essentially sandblasted your way through history to get to a result that still needs more work. Chemical rust removers are not much better. The phosphoric acid products you dip parts into are effective enough, but they come with their own list of problems. They are expensive. A single bottle handles maybe a few small items before it is spent. They require neutralizing afterward. They sting if they get on your skin, and they still cannot reach inside a threaded hole, down the bore of an old pipe fitting, or into the tight internal cavity of a vintage hand plane. The rust hiding in those spots survives because the liquid can get there, but the chemistry stops working once the concentration drops. And sanding. Sanding is just slow, painful grinding. Fine for a flat surface, useless for anything with geometry. Here is what all of these approaches have in common. They are mechanical. They work by physically removing material from the surface. Rust and metal together, gone. The problem is that rust does not sit neatly on top of the metal like a coating you can scrape off. Rust is the metal. It is iron that has chemically reacted with oxygen and transformed into iron oxide. To fight it mechanically is to declare war on the surface of the very thing you are trying to save. The method we are talking about today does not fight rust that way, it reverses it. To understand why electrolysis works, you need to understand why rust forms in the first place. And the explanation is actually simpler than most people expect. Iron is a naturally unstable metal when it is exposed to oxygen and moisture. Left alone, it wants to react. It wants to bond with oxygen atoms floating in the air and water around it. When iron bonds with oxygen, it forms iron oxide. That is rust. The process is called oxidation, and it is essentially slow combustion at the molecular level. Iron burns. It just burns over years instead of seconds. When iron rusts, it is losing electrons. That is what oxidation means at the chemical level. The iron atoms are giving up electrons to the oxygen atoms. The bond forms. The rust grows, layer by layer, season by season. Electrolysis stops that process cold, and then it runs the whole thing in reverse. Here is how. When you submerge a rusted piece of iron in water and pass an electric current through that water, something extraordinary happens at the surface of the rust. The current pushes electrons back into the iron oxide. It floods the rust with the very thing it lost during oxidation. And when those electrons return, the chemical bond holding the oxygen to the iron breaks apart. The oxygen atoms release, the iron oxide dissolves. The rust literally falls away as a soft, loose, dark sludge. And what is left underneath? Clean iron, untouched, unharmed, exactly the way it was before rust ever started. That is not metal removal, that is metal recovery. And here is the detail that makes this method so powerful compared to everything else. The electricity travels through the water. Everywhere the water goes, the current goes. The current reaches into every threaded hole, every internal cavity, every hairline crack, every tight crevice. The water is the vehicle, the current is the worker. And that worker never gets tired, never rounds an edge, and never removes a single atom of good metal. Now, let us build the setup. Because the beauty of this method is that you probably already own most of what you need. You need 4 primary things for this setup. First, a plastic container. The size depends on what you are restoring. A 5-gallon plastic bucket handles most hand tools. A larger plastic storage bin handles big jobs like a full cast iron skillet, a set of wrenches, or a vintage vise. The critical rule here is simple. Never use a metal container. Metal surfaces will conduct electricity. If your container is metal, it becomes part of the circuit and the whole system goes sideways. Second, a DC power source. DC stands for direct current, which means the electricity flows in one steady direction rather than alternating back and forth, like the power coming out of your wall socket. The most accessible source is an old phone charger or a laptop charger with the end cut off, and the two internal wires stripped back to expose the metal leads. For smaller items, 5 volts is enough to run the reaction cleanly. For larger or more heavily rusted pieces, a car battery charger set to its lowest amperage setting works extremely well. 12 volts with 2 to 4 amps is ideal for serious jobs. Third, the electrolyte. Plain water does not conduct electricity well enough on its own. You need to add something to it that allows the current to flow. The magic ingredient is washing soda, not baking soda. Washing soda. The scientific name is sodium carbonate. It looks almost identical to baking soda, and it sits right next to it on the laundry aisle at the grocery store. A box costs around $2 and will last you for months of rust removal. The ratio is simple: 1 tablespoon of washing soda dissolved per gallon of water. Stir it in until it is fully dissolved. That is your electrolyte bath. Fourth, a sacrificial anode. This is just a piece of plain scrap steel or iron. An old piece of rebar, a steel bar, a discarded metal bracket. The anode is the electrode connected to the positive wire, and it will slowly dissolve and corrode as the process runs. This is by design. The anode sacrifices itself so that your valuable tool does not. One critical warning here: do not use stainless steel as your anode. Stainless steel releases toxic hexavalent chromium compounds into the water during electrolysis. The compounds are hazardous. Use plain mild steel only. No chrome, no galvanized, no stainless. Now for the setup itself. 5 steps, and none of them are complicated. Step 1. Fill your plastic container with enough water to fully submerge the piece you are restoring. Dissolve your washing soda into the water at 1 tablespoon per gallon. Stir until it is clear. Step 2. Place your sacrificial steel anode around the inside edges of the container. Many people bend a long piece of rebar and rest it on the rim of the bucket so the top sticks above the water line. The anode should surround your target piece as evenly as possible for the most uniform current flow. Step 3. Suspend your rusty target object in the center of the container so it is fully submerged, but not touching the anode. This is important. If the 2 pieces of metal touch, you create a short circuit. The current bypasses the water entirely. Nothing happens. Use a plastic-coated wire hanger, a zip tie, a piece of nylon rope, anything non-conductive to hang the target piece from a stick or rod resting across the top of the container. Step 4. Make your wiring connections. This is the step where people make the one mistake that costs them their tool, so pay attention. Connect the negative wire, the black wire, to the rusty target object you want to save. Connect the positive wire, the red wire, to the sacrificial anode you plan to destroy. Negative to keeper, positive to sacrifice, every time, without exception. If you reverse those connections, the current eats your valuable tool instead of the scrap metal. You will pull out a perfectly clean piece of junk and a freshly dissolved version of the thing you actually wanted to restore. Step 5. Plug in or power on your charger. Then simply walk away from the setup. Within a few minutes, you will see the reaction is happening. Small bubbles will begin rising from the surface of your target object. Those bubbles are hydrogen and oxygen gas being generated as the current breaks down water molecules. This is normal. It is expected. But it is also important to understand why you must run this setup in a well-ventilated area and keep it away from any open flame or ignition source. Hydrogen is flammable. The amounts generated by a small phone charger are genuinely tiny, barely measurable. But a car battery charger at higher amperage produces more, and you want that gas dispersing into open air rather than collecting. Outside on a patio, in a garage with the door open, on a workbench under an open window. Any of these work perfectly. Now leave the setup alone to do its work. For light surface rust, 3 to 4 hours is usually enough. For moderate rust, plan for a full day. For the heavily corroded, thick, flaking, crusty kind of rust that has been building for decades, leave it overnight, 8 to 12 hours. The beautiful thing about this system is that you cannot overdo it. Once the rust is gone, the current has nothing left to react with. The process simply stops. You can leave the setup running for 24 hours without any damage to the tool. It just sits there, clean, waiting for you. When you pull the piece out, it will look strange. The entire surface will be coated in a soft, dark black film. This is magnetite, a form of converted iron oxide that forms as a byproduct of the reaction. It is not harmful, and it is not something to worry about. Take the piece to a sink, Rinse it under warm running water and rub it with a rough cloth or a soft brush. The black film wipes away almost effortlessly. Underneath it, you will find bare, raw, clean steel or iron. The exact geometry it had before the rust ever started. Threads intact, edges sharp, stampings clear and readable. Now here is the one part of the process that requires immediate action. Bare metal rusts fast, faster than you might expect. If you let a freshly cleaned piece sit wet in open air for even a few minutes, you will see a thin orange blush of flash rust forming. The solution is simple and fast. Dry the piece completely the moment you finish rinsing it. A heat gun works well. Paper towels to absorb the water first, then heat to evaporate what remains. Once it is bone dry, immediately wipe on a thin coat of oil. Any oil works for short-term protection. A few drops of mineral oil, machine oil, or a coating of WD-40 works perfectly. For cast iron cookware, you skip the oil step and go straight to the oven for seasoning. The scale of this method is what makes it truly remarkable. You can run a single wrench in a coffee can with a USB charger, or you can fill a large plastic storage tote and run dozens of tools simultaneously. The cost is a few pennies for washing soda and almost nothing for electricity. Think about what this means for rusted garden tools passed down through a family. Old cast iron skillets abandoned because the surface looked too far gone. Box after box of inherited wrenches from a grandfather's workshop, each one made from real steel. None of that is junk, it is just oxidation. And oxidation is reversible. The people who know this method look at rusted tools the way a jeweler looks at a pile of uncut stones. They see what is underneath, not what is sitting on the surface. A box of someone else's forgotten tools becomes a working collection worth keeping. You now know exactly what they know. You have the chemistry, you have the method. The only question left is what you are going to pull out of the rust pile first. And once you see a completely restored piece come out of that bucket, you are going to start looking at rusted metal in a completely different way.